Welcome, everyone. We're here today to talk about how 3D printing complements the mold making industry. We have representatives from GoProto and HP to lead this discussion. My name is Kristen Mulherin, and I'll be talking through the slides with you today. I'd like to introduce our panelists. We have Jesse Lee. He is the president of GoProto. Jesse's a 25-year student of the rapid manufacturing space. He's been a part of an incredibly diverse product development programs, from early prototyping for products like the iMac in the 90s, through high volume additive manufacturing for complex projects like HP's 580 color printers. Listening to client partner needs, utilizing the latest and greatest array of manufacturing technologies, and working with the best people in the product development and manufacturing community is what Jesse finds most exciting. Next up, we have David Tucker. David Tucker is the Automotive Strategy and Production Development Manager at HP. He specializes in production systems and design for manufacturability. He uses pre-problem solving to eliminate failures before they occur by improving designs. He's a trained plastics process engineer and has released over 1,500 injection molds in the automotive, commercial truck, and high-tech industry. So welcome, guys.
Thank you. And you know, Jesse, every time we get together, I learned something new about you. I didn't know that you helped release the iMac. That's pretty cool. So.
That's cool.
So to get things started, we're just going to do a really brief introduction on GoProto, and then we'll get right into it. Jesse?
Sounds great. Thank you, Kristen. Appreciate it. So the purpose of introducing GoProto here is just to talk about what we bring to the table and why we are an expert in this space. And so what we wanted to show here in this graphic is our ability to work with clients from beginning, early concept creation of a product or a project all the way through production, whether it be low, medium, or high volume production. We've been in this space for several decades. We understand each of the processes very well. We are technology agnostic, so we can go through and really carefully work with you on your project from beginning to end to address all of your needs. So we wanted to talk here about the different processes that we offer. We start at concept models, which is a machine or 3D printed model that has a very accurate representation of your design. We then apply graphics and finishing to it to make it look like your finished product, so we can help you with that early ideation stage. And then we scale all the way down to the lower right into production. So next step would be 3D printing, which we do with our 3D printers. We have several commercially available technologies, one being multi-jet fusion from HP, one being stereolithography from 3D Systems, another being fused deposition modeling or FFF from Stratasys. And then we also work in the SLS or selective laser sintering and the DLP space as well. And then we do urethane castings, which is a kind of a precursor to injection molding, where you make a master pattern, silicone rubber tool, and then pour multiples into that silicone rubber tool. And those are simulations of injection molded parts. So we have ABS-like material, polypropylene-like material, polycarbonate-like material, fully cosmetic, great kind of early bridge type parts. We also specialize in CNC machining. It's a huge part of our service offering. And that would be quick turn on plastic and metal machined parts, machined from solid. Then into tooling and molding, which I know is near and dear to the hearts of many of the folks listening today. We make metal tools, traditionally manufactured, just made very fast, either from aluminum, soft steel, hard steel, highly polishable steels for clear parts and so on. We understand the injection molding space extremely well. We do both the tooling and the molding, and also secondary operations, so value add to molded parts, so we can deliver finished products. Then sheet metal, we do low volume to high volume, so we're interested in doing 1, 2, 5, 10, 50 parts, and then into the hundreds and thousands. And then the last space that we're going to be talking about today, well, second to last, is additive manufacturing, which is taking 3D printing technologies, applying the principles that we would use in higher volume injection molding to make high volume manufactured parts through the use of 3D printing, and that's called additive manufacturing. And then last, that's very important, is that we come at this from a place where we understand finishing, we understand value add and secondary processes that take your machined, injection molded, or 3D printed part and put on those final touches like inserts, color, texture, inspection that are going to make them usable parts. So beginning to end, we can help with projects.
I've worked as a procurement engineer for a number of years, releasing molding, and in that development area, having a facility that you can go to that can supply multiple technologies can really simplify that procurement process, and provides a lot of synergy and value add during that development. So
thank you, David. That's a
good to
big part
see
of
how
our
that
of the model
combination.
here, is to be able to help. Everyone is under very big time pressure to reduce cycle time, reduce design time, because the product life cycle is so much work. So our model of being able to support from beginning to end in one place helps with time compression, helps with design validation. You know, looking at part design early on. That's a big part of our focus.
And really prescribing the right technology too. I mean, if you're to a hammer salesman, every problem's a nail, you know, but sometimes you use the best tool to solve the problem, and having, you know, a diversified background definitely helps you stay agnostic.
Very true.
Great. Well, thanks, guys. So we'll move on to the topic of today, which is, when is 3D printing not the best option, and when does it make sense? Thought maybe, Jesse, you want to start with this first?
Yes, absolutely. So we kind of emphasize there the not the best option, because there are lots of times when it's a great option, but not is something as especially now with companies being really forced to cut costs and reduce cycle times on designing the product from beginning to end. There's a lot of emphasis on, oh, we could 3D print this part. And while that may be a good solution, it also may not. And some of the things to consider are things that we think about in product development, like tolerances, like surface finish, like repeatability, and things that 3D printing, while it's gotten better over time, it still has some of those factors that are making it not the best choice. I think we show in this graphic here 3D printing or additive manufacturing on the left, and its emphasis is good for unit volume from 1 to 50,000 kind of cost and so on. What we want to focus on, that with cosmetics, you're going to need secondaries. Not okay with paint. If you're not okay with some kind of, let's call it less perfect cosmetics, not exactly the same every single time, then 3D printing might be a great solution. But if you need to have those, say, the color or the texture molded into the part, then you really can't consider 3D printing. So it might be a good thing to consider, but not for production. Then cycle time. 3D printing is great for getting out quick parts. No tooling required. You can often make a lot of design, let's say, shortcuts in a way. You can have thick sections. You don't have to worry about consistent wall thickness and so on. So you can get your design out fast, but we all know that you can print a lot of parts, but not as many as with injection molding. So yes, you can get parts out quickly. There's zero tooling cost, but can you make hundreds of parts in 2 weeks, like you can with a multi-cavity injection mold, for example. So those kinds of quantities and lead time, when you graph them together, I think we'll show that a little bit later. You'll see that there's some times where additive manufacturing doesn't quite stack up as well as injection molding. Those are just a few examples. David, do you have any other thoughts or input on that?
Yeah, I see a lot of this being blended together, especially as we start to people get more used to additive manufacturing materials, and how those materials, although not identical to the injection molding material, they begin to correlate and understand how they relate to each other, that these transition points really start to blend together. And you really start seeing the value of additive when you can reduce the number of changes and go to market faster. And when you understand the material, that that's really the power of digitization, I think, and that's where people are really trying to go.
Agreed. Yeah, I think that's pretty good cover there on that.
Yeah. So in terms of the product life cycle, again, stemming from what we were just discussing, we see a lot. Additive manufacturing technologies tend to be used for your prototyping and ramp in your ramp volumes. But we're seeing them going over into your actual production, where this is going to be the part that in economic cases, lower volumes today, is actually going to be used to make a saleable product that's going to go to, be sold to a customer. And then also over in your service and aftermarket area, there's some really complex analytics over there to determine if the material is actually going to work, and a lot of engineering that has to occur to validate that something's going to work. Typically in that area, you might not have the engineers to be able to prove it out. So I always caution people to make sure you have the right resources to be able to deploy that. And then as you move up, I mean, there's other technologies. It's like your aluminum injection molds. I personally love aluminum injection molds. You can cut them really fast. People sometimes do development and research work on aluminum injection molds, and really, if you have a very specific material or very specific material outcome that you're looking to use, and it's a great solution. Up into steel injection molds when you get to higher volumes, or even lower volumes, but you have like really crisp shutoffs or something that you have to achieve like a fine dimension on. But really, where the value of additive is when you start to accelerate your time to market. So, and what this means is, like, as you go up this curve, like, you're going up the curve faster, and you're also going up it sooner. So, and what we see that is, like, people that are gaining a competitive advantage is when they start to understand how those materials actually work. They can validate their designs faster, which enables things like functional prototyping. They reduce the cost of engineering changes, saving a lot of capital expenses. And really, where the best value is when people take a systems approach and say, well, I have a high volume product. Let's say I'm minimizing my number of my platforms that I'm going to have, but I want to offer a bunch of SKU variations on that platform. So enabling a certain level of customization, your ability to leverage two different designs. You can get pretty smart and take those systems approaches to take additive manufacturing all the way to the top, in conjunction with injection molding technologies.
Great. Well, I think we have now, built on that foundation, we're going to talk about some real world applications.
Yeah.
David,
So
this
is
is
probably my
yours.
favorite. Yeah. This is one of my favorite. This is the example that I like I said earlier, I'm an injection molding person. I've made my career building molds, and I've built about 1,500, all continents, all over the world. And when I realized the value of additive manufacturing, and really what it is additive manufacturing and multi-jet fusion specifically, is a flexible manufacturing platform. And in that platform, the way that you utilize that space and the way that you put parts inside of a flexible manufacturing place drives specific outcomes. So when I was developing one of our HP's 580 system, we ended up trying to prove out, like, well, how are we going to additively manufacture things? And part of that strategy was determining that it's like, well, what kind of parts are we going to produce, and how are we going to produce them? This was really that first point on the financial curve where we could start illustrating value. And really what we did is got the engineers intimately involved with the placing and packing of parts, so that they were concerned about build orientations. They were concerned about how these parts were going to thermally basically be manufactured next to others. When I looked at this, I started looking and said, so in the example here, this is 80 parts. If I was to release 80 injection molds, now granted, I could release 80 family molds, or let's say 50 family molds, and that's still a lot of molds. And it's really difficult it's expensive, first off, expensive to release molds. At the lower end, you're probably $5,000. At the upper end, you're probably $25,000. If you're into steel, you're even higher than that. But we're talking that many molds takes a lot of money, and it takes a lot of time. And I have typically, I'm manufacturing engineer. I like to be at the mold trial. And if I'm going to run 80 molds, I'm going to say it's going to take me about a week to do, using multiple tool shops. And that doesn't even include the mold build time. So, you could have weeks and weeks of doing this with a flexible manufacturing platform. And once you have the designs done, within 24 hours, you can have sample parts and actually start getting early feedback. Whereas if the others, I have to deal with inventory, I have to deal with mold trials, probably have to take a flight to China. I mean, there's a lot of complexity here.
Agreed. And then this is also repeatable. You know, you have an example here where we took these 80 parts and nested them. The picture on the left is a picture of a nested build in the multi-jet fusion process. And you could take that, that's called a Kanban build, where you take all of the parts and nest them together. You could take that and multiply it. You know, you could set probably 2 more systems worth of parts on top of that one. And so then you could scale it and you could print a significant quantity of parts in a usable material in a very short time.
Yep.
So if your product volume is pretty low, that could end up being your production potentially. If it's not, then it's certainly a helpful ramp, as you showed in that last slide. It gets you usable parts quicker and gets you up into analysis faster and helps you make that curve steeper and shorter. It's an incredibly powerful tool when used even in concert between 3D printing and the injection mold tooling.
Mm-hmm.
Yeah, great example. Okay, this is Jesse again. I'll speak about this. This is an interesting example especially to this group as well, because we managed this project. We 3D printed it. What the product is Mapper is a company that makes add-on cameras for drones, and they need a bracket that holds the camera in place on the drone. So the part we make is the part that's pictured in the right. There's 6 of them shown there, kind of 5.5. That part is 3D printed in multi-jet fusion, and then it's dyed dark green. And so the picture on the left, you can see the green part that we're pointing to. It's the DJI Mavic Pro mount. This is something where this customer is low quantity. They need something like 20 or so of these a month. The design is changing, as we all know. Drones and camera pieces, electronics, they change very quickly. So the product life cycle is extremely short. The usability in the market is very short. So committing to tooling is very daunting. They're not going to be able to get their money back out of the tool, most likely. And they have a very complex design. And so once we manufactured this project or product, and I spoke with the owner of the company and asked him some questions about how he's using this technology. And you see up in the upper right there, it says traditional method, meaning injection tooling or machining, I guess we could say. He said it was not considered due to the geometry, pricing, lead time, inventory control, and future design flexibility. So basically, he was taking advantage of all these things that 3D printing brings to the space. And as we looked at it, we didn't want to say, oh, you can't make this with an injection mold, so no, we can't do your project. Instead, having the ability to 3D print allowed us to say yes. And then as he builds his demand for the product and sells more of them, then it may make sense at some point in the future to be able to jump into an injection mold tool. So it's a great way to kind of get him started on it, get him going, allow him to focus on his product function, not worry so much about whether one of these features is going to create the need for another slide or a lifter. It really made it something that he could really focus on the functionality of his part. And then as he goes forward, we've had another one that I just had a conversation yesterday with another client saying, I now have enough orders that I think I can justify an injection mold tool. And so since we've been along with them on the whole ride, then okay, that's an easy one to go in and analyze quickly and get a good quote for. So looking at this again, the advantage here, HP MJF additive with GoProto added flexibility for just-in-time inventory. So what he does is he orders, I said he needs something like 20 of them a month. He orders 5 or 6 of them at a time, or he might order an entire month and have it's very low inventory. He's located domestically, so shipping is extremely low cost. It makes it very low commitment, very low cost for him. Design flexibility, allowing for printing of parts not possible with conventional methods. So any of you that have made tools before, you can see that there's a lot of very complex angles on here. There's features that are kind of coming in from the side, holes in different places that would make for a very, very complex injection mold if it was even moldable at all. So you get this idea of kind of complexity for free with 3D printing. No tooling required. That's a big advantage, obviously. And then the part price hits his target at the low quantities. Lead time is very quick, and the material is this nylon 12 dyed green. Now, some of the disadvantages are that if he wanted to suddenly, if he got a big order and he wanted to scale up and it was tens of thousands of parts, he would have a hard time doing that with 3D printing. We've worked through tolerances. That's a question of like, how well does this thing fit onto that injection molded housing of the Mavic Pro, and that was something we needed to work through, but we were able to get to the point where it worked very well for him. So really a good example here of something that was you're expecting capability similar to what you would get from a traditionally manufactured part, but you're using a 3D printing technology to make it happen.
Hmm. I'd like to point out that there is a lot of let's say like inertia of knowledge of how you actually mold that prevents some people from thinking innovatively about how do you actually combine features and make unmoldable features. So it really takes a mindset shift going into it to challenge yourself to recognize it's I'm going to make some unmoldable features and I'm okay with that because I'm trying something different.
That's
Yeah.
true.
And a lot of management has to recognize that too, that you want to adopt a new technology, it requires new perspectives, new mind shifts, new goals and objectives of how you're actually designing.
It does. And you mentioned earlier that on that 580 example that you did before, the 580 system Kanban build, you may want to consider in part design, for example, that a feature could affect how well parts fit together in the 3D print build platform. So if you can say move a boss around where normally we would have thought, well, we need to move it around because of a slider lifter that would be impeded by that boss. Now you want to move it around so that parts nest together better.
Yeah, exactly. Different financial outcome, but different method. Yeah. Think about the manufacturing process and how you optimize it.
Yes, that's exactly right. So good example there.
So it looks like we do have a couple questions. First one being, last two examples were based on 3D printing. When would you choose injection molding over 3D printing?
It's a good question. David, do you want to take that, or would you like me to?
Yeah, it's very, today there are limited material sets or attributes that you need out of a material. For instance, if you need a material that's, I think the clearest one, the one that comes to your mind is I want a clear material. Clear materials with good UV resistance, not a whole lot of additive manufacturing processes are able to deliver that. So that would be one where it's like if you have a very specific material attribute, or if it's, I want to design into a part on a material level, like friction resistance or lubricity inside of a part that's going to require, a very specific resin that's designed to do that function. You can get around some elements using design, but you can't get around functional attributes of materials. So from a material standpoint, that could force you into design yourself into utilizing a traditional approach.
Yeah, that's right. I would also say quantity plans. If you end up with higher quantities, we've done a lot of cost benefit analysis between the technologies, and we tend to see that 3D printing makes a lot of sense in the part of the graph that's under the mold cost. And then once you get beyond that, then you start to see that the equation flips and starts to be in favor of injection molding. So it would play out well if your quantities were basically a little higher.
Mm-hmm. I think another element there is understanding your market. Like if you really understand your market and that you can actually get to the volumes that you're going to get to. Mm-hmm. I've been involved in a lot of projects where, to be honest, they don't get to their volumes that they need, that they planned on. And they've built steel molds because everyone expects to be really successful with things, and sometimes aluminum tooling is the best solution. And not a lot of manufacturing facilities want to deal with aluminum tooling. Because it's, sometimes you move around, it can get damaged, so looking at that, like that midpoint is also important.
Agreed. Yeah, those are a couple of good points.
We have time for one more question. If costs are equal, which one do you choose?
It's a good question, and unfortunately the answer is that it depends because there are so many variables that can play into it. I would say that if we all look at things like design complexity. We talked about design flexibility for the future if you want to change something. There's of course cost, which you just said if it's equal. So we'll think of the other variables. There's time. There's part quality, surface finish, cosmetics. So if you enter any one of those, it can change your equation around. But I would. It varies a lot. The exciting thing is that it's becoming much more competitive for 3D printing than it has in the past. The addition of Multi-Jet Fusion into the marketplace means that you can get more production quality parts out of a production material, nylon based at this point still, You can get more of them in that material than you could in the past, and they're much at a much faster rate and at a lower cost. So that's exciting, but it still hasn't replaced injection molding. And so if you enter in those other things that I mentioned, you might skew the equation to make it be that injection molding is still a clear winner. But sometimes it just is. It's still the right fit.
I would, I think I'd want to point out here. I've been in lots of scenarios where people will go out and they will market test technologies. So they'll go and they will speak with someone who does additive manufacturing and someone that does injection molding, and they'll do a cost comparison. Typically, there's the way that you can reduce costs is by removing risk. So having discussions with your provider that's providing those solutions, someone that provides both, like GoProto, for instance, to help them understand all of the risks, so that they understand they have the ability to quote you accordingly. Right. So better communication equals better pricing. So a better solution to costs are equal. Dig deeper. And then the second point is, this is a rapidly changing industry, and it's one of the industries where you learn something, and then at the next Amerimold or the next trade show, you learn something else, and there's a new economics or new approaches to it. So it really is something industry and technology that you have to continue to engage with. And once you believe that you understand where the transition point is, you learn something else and it moves.
Yeah, well summed up, David.
Great. Well, thanks, guys. We have, if you have any additional questions, you can reach out directly to Jesse here at this phone number, or if you have any more general inquiries, you can shoot it over to quotes@goproto.com. Thanks a lot for taking the time today. Jesse, David, any closing words?
Thank you, appreciate it, and looking forward continually. As David mentioned, the technologies continue to advance, and it's exciting to be part of this on all fronts.
Great.
Yeah.
Thanks, guys.
Same here.
Thank you very much. Appreciate it.